Hi, my name is Vitor Firmino, and I'm going to present the paper Lung Pattern Classification for Interstitial Lung Diseases using a deep convolutional neural network. We have the authors here, and here is my name. So, in this paper, the authors proposed and evaluated a convolutional neural network designed for classification of interstitial lung diseases patterns. Uh, we have 7 classes. Six of them are related to this lung diseases, and one is for the healthy uh, people. For this paper, the dataset that they used was provided by two different Swiss university hospitals, which were taken from ILD CT scans. Here is an example of the scan that they got, and these little squares here are the way that they got the characteristics or the features from the image. So using these little squares, they got 14,696 image patches from 120 scans. So here is an example of the image patches that they got from the scans. The CNN proposed consists of 5 convolutional layers with 2 by 2 kernels and leak ReLU activations, followed by one average pooling with size equal to the size of the final feature maps, and 3 dense layers. The last dense layer has 7 outputs equivalent to the class considered, um, where one of them is the healthy patient and the 6 others are related to um, lung diseases. Here we have the representation of the CNN that they developed, where the first one is the input. Then we have 5 convolutional layers with leak ReLU uh, activation function, and we have a 2 by 2 kernel. And here we have the average pooling. Then we go to the fully connected layers, where the last one is the one with a softmax function, activation function, and these 7 neurons here are the same amount of the classes to be classified. So they have tried different configurations for the CNN, and the best one that they got was this one here with a dropout function of 0.5 using 100% of pooling percentage. Uh, and the kernel size with 2 by 2, number of convolutional layers 5, and then they got like 0.8547 F score and epoch times 286. Uh, and yeah, and here we have the results. So the first thing that they did was to compare the optimizer and the loss function, where they tried the ADAM and the cross entropy, and they got better results than the other ones. Then they compared their result with the results of the state of the art, where they outperformed with their model when compared to the other ones. And finally, they also compared their proposed method, their CNN, with the CNNs uh, that are already tested in previous papers. So it's clear to see here that they outperformed all the other models, uh, almost with 7%. uh, of improvement. So, about this paper, we can say that the model's complexity is really large, um, big. We have a large amount of data, and uh, it takes a few hours to train for training, which makes it a really slow process. So they could improve uh, their parameters of optimization process, and also they could improve their architecture. So I think that they could select a little bit better their features, so they don't need to use like almost 15,000 images. I think it's a lot of images, and they could kind of decrease this amount of data to take a little bit less of time of training. So that's it. Thank you.